Welcome to Science Chomp. Today we're going to be looking at distance time graphs. On a distance time graph, you have two axes. On the y, we're measuring distance in meters, and on the x, we're measuring time in seconds. And you're going to encounter three different types of line. The first is a positive upward slope, like so. The next line is a horizontal line, like so. And the final line is a negative slope, like that. Okay? The positive upward slope, this determines constant speed. Note, it is not acceleration, it is constant speed. The horizontal line denotes that it has stopped because the distance hasn't moved from here to here. And if the distance hasn't moved, then the actual person or object hasn't moved either. So this is stationary, which is another way of saying that it has stopped. If they asked you to work out the speed for this, the speed for any horizontal line on a distance time graph is 0 meters per second. And the final line down here, it is not slowing down, rather, it is returning to the starting position. So it's returning to start. Okay? There's three types of questions that you're going to encounter. First of all, it's going to be something like work out the speed of this part of the graph. Secondly, it would be work out the average speed. And finally, they could say, how long has this person stopped for? Okay? Let's do that one first. How long have they stopped for? Well, if it's stopping, well, if they originally stopped at, let's just say 3.1 to, I don't know, 8.5, the amount of time that they have stopped for is 8.5 minus 3.1. Okay? Very easy calculation right there. The more important one to be able to work out is speed. Okay, now we should know that speed is equal to distance over time. Okay, and in this case, what that will give us is a slope, the slope of the graph. And the slope, same in maths, is rise divided by run. So let's work that out. Let's just get rid of some of this over here and over here to give us a little bit of space. Now, to work out the slope, you've got to draw a triangle against this line. Doesn't matter how big or how small the triangle is, as long as it's a right angle. So let's just do like this. Okay? The rise is this part here, and the run is across here. So to work out the rise, you go across, and it's giving us, let's just make it easy. Let's say it's 3. And this one is 1. And the rise would be 3 minus 1, which will give us 2. Okay? 3 minus 1 is 2. And down here, for the run, you find out the end bit, which is, again, 3 on the bottom axis, minus this one, which is 1. And again, it gives us 2. So the rise is 2, the run is 2, which gives us 2 divided by 2, which is 1 with the unit meters per second. Okay? To work out the average speed, what we must find out is total distance divided by total time. If you have a look at the total distance, we're going up to 4 meters up here. We've stopped, so if you're stopped, you're not moving at all, so that's 0 meters. And then you're returning back to the start, so that's another 4 meters. So it's 4 plus 0 plus 4, which is going to be 8, divided by, and the total time is going to be here, let's just make it easier, let's just call it 12. 8 divided by 12. I can't do this off the top of my head, but maybe you can. And if you can, put it in the comments section below. Thank you for watching. Goodbye.